Using a 3-4-5 triangle to square a building. An important part of ensuring a building is constructed correctly is getting the building square. This means that each corner of a rectangular building is a 90-degree angle. If we can make the building square, the rest of the building process becomes easier. Builders have a few tools to help them. One of these tools is borrowed from mathematics. In building, we call it the 3-4-5 triangle. Using the 3-4-5 triangle, we can make the corner of our building square. A triangle with one 90-degree angle is called a right-angled triangle. Pythagoras, the Greek mathematician, found that if we square the two sides forming the right angle, which means that we multiply the length of the side by itself, and add them together, the square root of this number will be the length of the third side. This also applies to the 3-4-5 triangle we use in building. The 3-4-5 triangle rule states that if we travel from a point 3 units in any direction on a fixed plane, e.g. a piece of paper, and then at right angles, 90 degrees, 4 units in another direction, the line between the two other points will be 5 units long. In building, we may wish to double, triple or halve these dimensions to make our triangle bigger or smaller. So long as we multiply all three numbers by the same amount, our triangle will remain a right-angled triangle. And we see up here, we have a 3-4-5 triangle. So this side here is 3 units long, 1, 2, 3. This side here is 4 units long, 1, 2, 3, 4. This unit here is, this side here is 5 units long, 1, 2, 3, 4, 5. Squaring the length of the side means that we multiply it by itself, so we've gone 1, 2, 3 times 1, 2, 3, and then if we count all the units, we've got 9. This side here, we've gone 4 units, 1, 2, 3, 4, by 4 units, 1, 2, 3, 4, 5. We square all of those, we get 16 units, and then this side here is 5 units long, 1, 2, 3, 4, 5, by 5, 1, 2, 3, 4, 5, and if we add all those units up, or multiply 5 by 5, we get 25 units. The squared number of units here, which is 9, plus the squared number of units here, which is 16, equals the squared number of units here, which is 25. No matter how we extend the sides on our triangle, pulling it that way or that way, as long as this angle here remains a right angle of 90 degrees, we know that if we multiply the length of units on this side by itself, that side by itself, and then add them together and take the square root of that number, we'll end up with the length of this side here. So that's Pythagoras' theorem.